Continuing with section 2.9, looking at example 3. So let H is equal to span of V1, V2 be a subspace of R3. And let B is equal to V1, V2. So B consists of two vectors V1 and V2, where V1 is 362 and the vector V2 is -101. So part A, then B is a basis for H equal to span V1, V2. So this is given that H is a span of V1, V2. So why can we say that B is a basis? Remember, we have to check two things, that the vectors in the basis, they are linearly independent, and the other thing is that they span the subspace. So from this given information that H is equal to span of V1, V2, it's telling us that V1 and V2 span the space H. So one condition is met. Now we have to check whether they are linearly independent or not. Well, you can always check by using the reduction, row reduction. So 362 -101, then you can put 0 0 0 there, because remember, in order to be linearly independent, we want to see that the solution of A x equal to 0 is the 0 vector. So it gives us x is equal to 0. That's what we want to check, the trivial solution. But also you can check by, so you put a vertical line here, augmented matrix. So this is, you are checking C1, C2 or D1, D2, whatever you want. So these are two coefficients because we have two vectors. So then you perform the operation of row reduction and then get it into the echelon form, and you can tell whether both of them are linear, they make a linearly independent set or not. The other way to check, easier way is quicker and easier way is to check if they are multiples of each other. So by looking at them, you can tell that they are not multiples of each other. So we say V1, V2 form are linearly independent. We can just say, so these are linearly independent. And span H. So B is a basis for H. So remember, we did an example earlier, the first example, where we had three vectors and we noticed that not all three are spanning. I mean, all three are spanning, but all three are not making a independent, linearly independent set vectors. So we had to throw one of them out. In this case, we are given two and they are linearly independent and they are also spanning the set. So we say that B is a basis. B consisting of those two vectors is a basis for the subspace. Now the next part is that if you are given a vector, let's say 3, 12, 7, first thing is determine if x is in H. So first thing we have to check if x is in H, and if it is, find the coordinate vectors of x relative to B. Now to check whether x is in H or not, what we have to do is we have to see that can we write x as a linear combination of vectors in B. So we'll say, so we want to find C1, C2. So these are scalars such that such that x is equal to c1 v1 plus c2 v2. Now, if the system is consistent, we will get values for C1 and C2, which will mean that X is in H, and also these numbers C1 and C2, they will be our coordinates for the vector X relative to B. So basically again we are solving the system of equations 3, 6, 2, negative 1, 0, 1, and then I have 3, 12, 7. So notice here we are solving a 3 by 3 system again, but now we have a straight line here because the coefficient matrix was only 3 by 2. So this gives me, what I will do here, because the second row, if I multiply the second row by 1 over 6, I am getting a 1 in the first column. So I'll swap row 1 and row 2. So I swap these two rows. Now I multiply the first row by 1 over 6. So I get 1, 0, 2, and 3, negative 1, 3, and 2, 1, 7. So now I can easily use this as a pivot and then reduce the numbers below this pivot to 0. So I have to multiply the first row by negative 3 R1 plus R2 and negative 2 R1 plus R3. Which gives me, the first row is 1, 0, 2. Second row 0, negative 1, so we multiply by negative 3, so we get 6. 6 minus negative 6 plus 3 is negative 3. Third row is going to give me 0, 1, 3. So now you can do it in two different ways. So I am going to first add the second row into the third row to make the last row 0. If you add the third row into the second row to make the second row 0, remember a row of zeros always you have to bring it at the bottom. So if you make these zeros, then you have to swap these two rows. So this goes in the second place. But I am going to add the second row into the third row. So I get okay. So now what do? I multiply the second row by negative 1. from here I get C1 is equal to 2 and C2 is equal to 3. So which is giving us two you know two things. One is that yes, X is in H. Then say system is consistent. So X is in H. Okay. And now also we can say and the coordinate vector of X relative to the base B is equal to 2, 3. Now note here X was a 3 by 1 vector because it was in R3, but in here now the vector relative to base B is a 2 component vector because it's in on the plane, so it's in 2 by 2. So here we can see it geometrically. What it means is that you have this plane and you have these vectors, so we can create a new grid of with our vectors as our axes. So you can extend this one and that other side because that's how it will be. So this much is V1 and this much is V2. So how much we go along V1 and how much we go along V2. That's how, remember, we read the vectors in the xy plane. So if you have x1, x2 plane and your vector is coming here, how do you read it? You go say, okay, how much did I go along the x1 axis and how much did I go along the x2 axis? So same thing, if we are looking, this is our x, and we can see that we go 2 v1s and 1, 2 and 3 v2s. So these are the grid points with the v1 and v2 lines, parallel lines intersect, and so that's why the coefficients of v1 and v2 are 2 and 3. The last example here. So let b1 is equal to 0, 2. This is an extra. It's 0, 2 and b2 is 2, 1. X is given to be negative 2, 3 and the b is equal to b1, b2. So this is the basis for our subspace. So it says find x, the coordinate vector x relative to b. How do we find it? We just did an example like this. We want to see how can I write x as c1 b1 plus c2 b2. So then we are solving the system of equations. So what will I do? Because the pivot has to be a non-zero entry, so we swap row 1 and row 2. Okay. Then I can multiply the second row by 1/2. To get my answer, I have to make this entry 0. So I will multiply the second row by -1 and add in the first row to get 2, 0, 4, sorry, yeah, 2, 0, 4, and then the second row is just 0, 1, -1. Then I multiply the first row by 1/2. Well, you can go from here and just do the back substitution and get the answer. So I try to go to the make sure that I have the row reduced echelon form. So from here I can now say directly that C1 is equal to 2 and C2 equal to -1. What does that mean? Means the x vector coordinate vector of x relative to the basis b is equal to 2, -1. So now you must have understood how to go from the standard basis. So this is in standard basis. This can be thought of as -2e1 plus 3e2. So standard basis in R2. So, and now we have it written in the basis B. But how to come back from basis B? So if you have given a vector u, w, which is actually the coordinate vector of relative to w relative to basis b is 7, -5, and how can we find w? So remember the relation is that this vector b is equal to, so because it's 7 -5, so it will be 7 b1 plus -5 b2, or 7 b1 minus 5 b2. So now you just plug in b1 and b2. 7, 0, 2 minus 5 into 2, 1. So we get 0, 14 minus 10, 1, 10, 5, which is equal to, so 0 minus 10 is -10, 14 minus 5 is 9. So this was the actual vector which was converted into the coordinate vector of relative to b. If you try to convert this by using the method in part A, if you want to convert this into, so this is your w actually, into the coordinate vector, you should get the 7, -5. So in this section we have learned how to go from a standard base to base B, and here in the part B we saw how to get from a base B to standard base. Now in chapter 4 we will learn how to go from base B to a base C. Now we can go to base, from base B we can go to base C by going via the standard base. So we can go, if we are given xb, we can go to make it x and then convert the x into coordinate vector relative to the base C, another base. But in chapter 4 we will learn how to go from here to here directly, and then backward as well. So this is all you need to know from section 2.9.